So in our last video, we figured out how to get the percents of each element in a compound. Well, today, look, if you read this problem, they gave us the percents. They said this compound is 74.8% carbon and 25.2% hydrogen. And they want us to figure out the formula. So the exact opposite of what we were doing. So let's figure it out. So first, I write down the percent. I'm making a table, and normally we do just follow along with the table. And you don't have to make a table, but you have to have this one near you so that you don't miss a step. I write down the percent as grams, and I divide each of the grams by its molar mass, and that way, this is grams, and this is grams. I divide each one by its molar mass, and I get a number that's moles. So this is moles, and this is moles. But to be able to write a formula, I can't have decimals. I can't write carbon 6.2333 and hydrogen 25.2. I've never seen a formula like that. So I have to make it a whole number ratio. So to do that, I divide each of the numbers by the smaller of these two answers. Like here I have 6.2 moles and 25 moles. So I divide each by the smaller. The smaller in this case is 6.233. I divide each by that number. And here I'm going to get 1 because I'm dividing a number by itself. And here I get 4.04. So the ratio is 1 to 4. So that means there's 1 carbon and 4 hydrogens. And so this is the formula. This formula has a name. It's called the empirical formula. This is the most reduced, the simplest form. This is the empirical formula. And it means a formula that is in the lowest, you can't simplify more. So I can't, like 1 and 4, I can't divide them, I can't make them any smaller. So that's what the empirical formula is. So what if I don't get a whole number? What if I don't get 1 and 4? Well, if I I have another problem that I'm going to show you that where that happens, and I'll show you what you do. You're going to multiply by a 2 or a 3. Okay, and so that's this page 15. And so the other problem that I wanted to show you is this one here. I wanted to show you a more, like, here's another problem. Notice this time I don't have a table. I'm gonna do the steps. This problem said I have carbon and hydrogen and oxygen. So I write down carbon and hydrogen and oxygen. And I write down the percents of each. I cross out percent and put the same number down as grams. Grams. I divide each one by its molar mass, and I get moles. Here I get 4.9 moles, 9.8 moles, 1.9265 moles. And then I look to see which of these 3 numbers is the smallest one. I'm going to divide all of them by the smallest one to get a whole number ratio. So I'm going to divide by 1.9625. I'm going to get, I'm dividing a number by itself, so I get 1. Here I got 4.99, which I'm going to count as 5. Okay? And this number here, 2.49, I can't round that to anything. This is going to be 2.5. So what do I do here? This is that step I was telling you about, where if I don't get whole numbers, I have to multiply. Okay? I have to multiply by a 2 or a 3. So in this case, I'm going to multiply everybody by a 2. Why 2? Because when I multiply 2.5 times 2, I'm going to get 5. What if this number was a 2.33? I would multiply by 3, because when you multiply 2.33 times 3, you get 1. So I multiplied by 2, everybody by 2. So here I'm going to get a 5, and here I'm getting a 10, and here I got a 2. Okay, and so now I can write the empirical formula, the formula that is in the lowest terms. Carbon 5, hydrogen 10, oxygen 2. Okay? So that's how I get the formula. That's how they gave me percents, and I use those percents to get a formula. So, and I find the molar mass of this compound, and it's 102 grams per mole. Why do I need the mass? Because this problem went on, and it said, I want you to find the molecular formula. The molecular formula is not the one that's the most reduced. It's the multiple. Okay? So it's the multiple of this. So empirical is the most reduced. Molecular is the multiple. And I always remember, because M molecular, M multiple. That's how I remember it. So now I'm going to go in and I find they gave me the molar mass of the molecular. And so I put that down. I divide by the molar mass of the empirical that I got, and I got a 2. Okay? Okay, so here's the empirical formula, and here's its mass. And they gave me, in the problem, they gave me the mass of the molecular formula, 204. So I'm going to divide the molecular formula, molecular mass divided by the empirical mass, gives me the factor that I need to use to multiply by. So 204 divided by 102 is 2. And that means I'm going to multiply the empirical formula by 2 to get the molecular formula. So it's going to be 5 times 2 is 10, 10 times 2 is 20, and 2 times 2 is 4. Okay, and that's how I got this empirical formula. And I put the formula in there for you. So you multiply the empirical times 2, and I got the molecular formula. And that's how I go from having percents all the way down to having the molecular formula. Okay, and there's a bunch of problems on these 2 pages, and I want you these are pages that you're going to have to submit.